Hey guys, happy virtual instruction day 2. So yesterday was an ed puzzle. The day before that, seems like forever ago, was a worksheet over global winds. Don't want to do a whole lot new, so we're kind of continuing with that, just kind of extending it, okay? Some of you might be thinking this is a bit repetitive, but hey, it's okay. Let's have a good foundation of this so we can better articulate ourselves when we do have to kind of talk about it, okay? So this one's about ocean current worksheet. Well, that's what it's called, but it's about ocean currents, which follows really closely to the wind, global winds. Okay, so I'm making this video to like as if I'm walking through it in class with you. So if you don't need this, don't watch it. Just do the worksheet. But if you like to hear me kind of read it and go through it, you can. I'm not going to be necessarily answering anything, but I am just going to guide you, and you'll still have to do the worksheet yourself. Okay. So you have this ocean current worksheet in classroom. I'm going to read it to you. Here we go. Do open it with Cami. I would split screen it and work with me as I do it. So temperature affects the surface currents. So surface waters of the Earth's oceans are forced to move primarily by winds. Where wind blows in the same direction for a long period of time, currents will develop that transport large masses of water over considerable distances across ocean currents. So, why do ocean currents and global winds move in a circular pattern? You guys know the answer. The circular pattern is caused by the Coriolis effect. The Earth's rotation on its axis causes ocean currents and winds to curve to the right or clockwise direction in the northern hemisphere and to the left, which is the counterclockwise direction in the southern hemisphere. As the winds and currents move, the Earth rotates underneath them. The currents appear to curve in relation to Earth's surface. If the Earth did not spin on its axis, then the currents and winds would appear to move in a straight direction. Side note here, what they're saying, you saw this kind of on the Ed Puzzle yesterday, and if you haven't watched the Ed Puzzle, watch it. So cold is cold up here, right? It's warm down here. So when warm air rises to the top, if the earth did not turn, it would just come straight down. But like a cake, like you like marbled cakes and they swirl because the earth does rotate, there are swirlies. That's why we see swirly clouds and from space, right? So let's look at this diagram here. It says due to Earth's rotation, objects deflect to the right in the northern hemisphere, and then objects deflect to the left in the southern hemisphere. Okay. I hope we can get back to class soon so we can actually do a demonstration of this. Part 1, they want you to compare the two pictures below. It has the ocean surface current patterns and then global wind patterns, and we're getting familiar with our equator and then 30-60 north and 30-60 degrees south. Same thing here. Again, this is showing ocean currents and this is showing wind. So take a look at the two pictures, and what do you notice about the global wind and surface current patterns? In general, the direction of the wind flows in the blank direction as the ocean surface currents. So just kind of look at your arrows. Is it going clockwise or counterclockwise? Okay. Okay. Part 2, using the table below, label and color the currents in the picture. So red, you'll have to go over here to the drawing, and you can click on the red. And they want you to color where it says warm, you will have to color it. This is more of a burgundy color. You can change the color here. Where it says warm, you have to find that numbered arrow. So again, warm, the Gulf Stream, so number 3, you'll have to color it red. Okay. And I don't want to color over that number because I kind of want to remember what that was. And then number 4, the Kuroshio current is number 4. Sounds Japanese, which is why I went over here. Okay, so that's red. So I did that one. East Australian current. Hey, isn't that in Finding Nemo? Number 5. Hey, look, it's over here. Okay. I'm pretty sure that's in Finding Nemo. Correct me if I'm wrong. So anyway, color that. Color all those. Where it's cold, make it blue, I think. Yeah, I'm not done, but y'all do that. So after you're done doing that, you have a few questions to analyze over this and just type in your answers. Uh, and complete any other missing work, okay? So this shouldn't take you but maybe 15-20 minutes if you do it methodically and intentionally. If you have any questions, please email me. And I hope you guys stay safe and have a good